Hi and a very good day to everyone. So in this video, we will be doing a very short and quick revision on SPM physics topic, which is radioactivity. So in this topic, you will need to understand the nucleus of atom, the radioactive decay, uses of radioisotopes, and the nuclear energy. Okay, let us look into the first subtopic, which is the nucleus of atom. So in this subtopic, the questions often ask you to define what is the proton number, nuclear number, and isotope. So proton number is just the number of protons, or you call it as atomic number, Z. Nuclear number is the total of nucleons, or mass number, A. And the nuclide, the symbol is X. The upper part is A and the bottom part is Z. And the isotope, it is atoms of element having same proton number but different nuclear number. Okay, next is the radioactive decay. So what is a radioactive decay? It is the radiation emitted by unstable atomic nuclei as they attempt to become more stable. The three kinds of radioactive emissions are namely alpha particle, beta particles, and gamma particles. Alright, these types differ in velocity in which they are affected by magnetic field, and their ability to penetrate matter is also different. So for alpha particles, their neutral properties is helium, so the charge is positive. For beta, the natural properties is electron, so as you know electron, it is negative. And for gamma, electromagnetic wave is neutral, so it won't be affected by magnetic field. Alright, so in terms of penetration, the penetration rate for alpha is very low, so it can be stopped by a sheet of paper, so it has a low penetration. For beta, the penetration rate is average, so it can be stopped by a few millimeters of aluminium, so it has average penetration. And for gamma, the penetration rate is very high, so you will need a few centimeters of lead needed to filter the rays. Okay, so here is just a short explanation on what is radioactive decay. So to explain radioactive decay, it is actually a spontaneous disintegration accompanied by the emission of energetic particles, or we call it as photons. So the nucleus, the bigger nucleus here, we call it as parent nuclide. So parent nuclide is actually unstable, so it will undergo decaying process to become more stable. So after it has decayed, it will produce the daughter nuclide. These are all the daughter nuclide, or in other terms, it is called a more stable nucleus. More stable nucleus, yes. In this section, I am going to show you the equations to represent the changes in the composition of the nucleus when the particles are emitted. Okay, so for alpha decay, the emitted particle is alpha particles, or helium. Helium has the nuclear number of 4 and the proton number of 2. So when the element of X is undergoing a decaying process, it will release helium. So the new product, or the new element, the nuclear number will -4 and the new proton number will -2. Okay, so for beta particles will emit electrons of nuclear number 0 and proton number of -1. Okay, so when it is releasing electrons, the initial element will produce a new element of Y with the same amount of nuclear number, but the proton number will add 1. And last but not least is the gamma particle. Gamma particle, the decay will occur when an unstable nucleus releases its excess energy in the form of gamma rays. So the equations is just simple. The initial element will not produce any new elements because it will remain the same, only that it will release excess energy in the form of gamma rays. Alright, so now we will look at half-life. Half-life is the time required for half of atoms in a radioactive substance to disintegrate. Okay, so now let us do one example of half-life case. So sodium-24 has a half-life of 15 hours. What fraction of sodium is left undecayed after 60 hours? So you know that the half-life of sodium-24 is 15 hours. Just highlight first. What fraction of sodium is left undecayed after 60 hours? So the question wants you to find the half-life after 60 hours. Alright, simple. So first, you just find the equivalent of 60 hours. 60 hours is equivalent to 4 half-lives. Right, how do we get this? Just 60 divided by the half-life of the sodium-24, which is 15 hours. So you will get 4 half-lives of sodium-24. So we want to know what fraction of sodium is remain. So the undecayed natrium or sodium is just half the power to the power of 4, which is 1/16. So the fraction of sodium that is left is 1/16 of the original. Yes. Next, let us define radioisotopes. It is actually atoms of a radioactive element having equivalent atomic number, which is Z, but different mass number, which is A. Radioisotopes are unstable and it will give off radioactive emissions during decay. So one of applications of radioisotopes is in medicine. It is used for diagnosis, treatment and research, while in industry, it is used to detect leaks. Last but not least, we will look into nuclear energy. So the first process is the nuclear fission. Nuclear fission is a nuclear reaction in which a single large nucleus splits into 2 or more smaller nuclei. So you can see here, this is the process of splitting up into smaller nuclei, which this one is more stable. This nucleus, the daughter nuclei, is stable. Alright, the second process is the nuclear fusion. So nuclear fusion is the process whereby multiple nuclei, it combines or join together to form a heavier or larger nucleus. And it is accompanied by the release of energy, depending on the masses of nuclei involved. So there are only two processes, which is nuclear fission and nuclear fusion. For nuclear energy, the formula that we will use to solve the problems regarding this subtopic is E equals to mc squared. So E is the energy released in joules, the mass in kg, and C is the speed of light. So speed of light, the value is 3 times 10 power of 8 meter per second. Okay, let us look at the example. So this question is involving a nuclear reaction, or we call it nuclear fission, because this single large nucleus, which is uranium, it splits into 2 or more smaller nuclei, as you can see in this question. Uranium. Okay, so the question is calculate the energy in joule for this reaction given. So it has the data given are uranium is equals to 235.0495 U. U is the atomic mass unit of 1/12 of the mass of carbon 12 atom. And rubidium 93.9216 the mass. Cesium 141.002 kg, and n is equals to 1.00 at 0087. Okay, so to solve this problem, first you need to write all the constants needed to solve this question. Okay, so take C is equals to 3 times 10 power of 8 meter per second, and U is equals to 1.66 times 10 power of negative 27 kg. Okay, so in this nuclear reaction, you need to find the initial mass and the product mass. So initial mass is the mass of uranium plus the mass of N, which is 235.0495 times plus with 1.0087, so you will get 236.0582 U. Okay, so for the product mass, which is the cesium and rubidium product mass, okay, the mass of rubidium is 93.9216 plus the mass of cesium, which is 141.002. You will and plus the energy release, N and the energy, so 2 times 1.0087. The answer will be 236.941 U. Okay, so when we have gotten the mass of initial and the product, we will find the mass defect. So mass defect, you just need to find the difference. 236 difference of initial minus the mass of the product minus 236.0582. You will get 0.8628 U. So substitute U, which is 1.66 times 10 negative 27, into this value, and the final answer will get 1.432248 times 10 to the power of negative 27 kg. Therefore, the released energy, or E, equals to mc squared. You have gotten the M, which is 1.432248 times 10 power of negative 27 times with the C squared. C is 3 times 10 power of 8 squared. Then finally you will get the answer of 12.89052 times 10 power of negative 11 joules. So this is the final answer. Alright, so that's all that you need to revise for this topic. This is just very quick and short, so I hope you understand, and please read more, revise more, because you will need to have a deeper understanding to solve all the questions. Okay, so I want to wish good luck to all of you who are going to sit for SPM, and may the force be with you. Thank you. Please comment and give feedback in the comment section below, and hit the like button. Okay, thank you very much. Bye.